Hey all, so I'm going to discuss the solution for boxes with candies problem from the Codesprint Prelims Intermediate contest. So let's get to the question. The question goes like this. There are n boxes arranged in a row and each box contains some candies. We are given an array candies which tells the number of candies in each box. And in one step we can choose a box either from the beginning or from the end of the row and take all the candies from it. And we can do this exactly k times. So that is, we can choose exactly k boxes. So our task is to find the maximum number of candies that we can get. So that's basically the question. And the constraints are that n is of the order of 10 raised to 5. That is, the number of boxes that we have are of 10 raised to 5. And here is an example input. So here there are 7 boxes and each box contains 1, 2, 3, 4, 5, 6 and 1 candies, and we can take 3 boxes. So either like we can take 3 from the beginning, in which case the number of candies we have would be 1 plus 2 plus 3, that is 6, or we can take 1 from here and 2 from here. In that case we have 1 plus 1 2 plus 6 8 candies with us, or we can take 2 from here and 1 box from here, so that will give us 1 plus 2 3 plus 1 4 candies, or we can take all the 3 from this side, in which case we have 5 plus 6 plus 1, that is 12 candies, and that is the maximum number of candies that we can get. So the output for that is 12. So that's the question. So let's see how to solve this problem with the help of an example. So here I have the candies array and the value of k is 3, which means we have to select 3 boxes. Now what are the possible ways of doing it? So one possibility is we can take all the 3 boxes from the right, so that gives us a sum of 8, or we can select 2 from the right and 1 from the left, so we have a sum of 17, or we can select 2 from the left and 1 from the right, that gives us a sum of 19, or we can select all the 3 from the left and that gives us a sum of 21. So this is the maximum sum, and what we can do is we can find all these individual sums and then find the maximum. So that is one approach. So let's see how that can be done. So if I have, say, x values that I can take from the left, then I can take k minus x values from the right. So using this, I will find these individual sums and then finally take the maximum. So that would look something like this. Say for x in range, so for x ranges from 0 to k. The range of x is from 0 to k, which means from the left I can take up to k values and nothing on the right. So for x in this range, I can find the sum of the elements of the array from the range 0 to x, and then I can find the sum of the elements of the array from the range k minus x to the end. So that is like, say if the value of k is say 2, then that would be this case. So like I have the first 2 elements selected from the left and 1 element from the right, and then that would give us these sums, and finally take the maximum and print the answer. So this is one way of doing it. And if you look at this, so to find the sum, we have to iterate over this array x plus k minus x times, which is k times. So this whole part would need to we need to iterate over the array k times, and the outer loop also ranges from 0 to k, which is k times. So the time complexity of this solution would be of the order of k square, and this would give us a TLE because the value of k is of the order of 10 raised to 5. So this would give us a TLE. So we need to come up with a more optimized solution. So let's see how we can optimize this. So right now what we are trying to do is we are trying to maximize these values, that is the 3 values which we take from either from one end or from both the ends. So instead of trying to do this, what we can also do is try to minimize the remaining values. So in this case, I can try and minimize these remaining values, and in that case I'd still end up with the required answer. The other values, that the required values, would automatically be maximized when we try to minimize the remaining values. And if you observe this, we can see that this the values that we supposed to be minimized always form a continuous section of this array. or they form a sub array, and they have a size of n minus k, right? Because if we need to select k values, then the remaining values in the array would be n minus k. So now this problem just basically becomes to find the minimum sum sub array of size n minus k. And once we find this minimum sum sub array, that is the minimum sum, all we have to do is take the total sum of the array and subtract the minimum sum. So then we'd be left with the maximum sum, which is our required answer. So let's see how we can find the minimum sum subarray of size n minus k. To do that, we'll be using what is known as a sliding window technique. So we'll see what that is. So the idea here is to basically first we'll find the sum of these four elements. Now the 4 is actually n minus k, that is 7 minus 3, and I'm calling this this a window, and we'll see why. So here first I'll find the sum of these four elements, and I will store it in a variable called sum. Now in the next step, to find the sum of these four elements, what I can do is I can add this 1 and remove the 10. That is, I can add 1 and subtract 10 to the sum that we got here, and so we get the sum of these four elements. And then we will so we need to minimize the sum, so we'll keep a minimum sum, keep track of the minimum and update the minimum if this current sum is less than the minimum sum, and we can keep repeating this process. So to get the sum of these four elements, I can add the 3 and remove this 5, subtract 5 from this sum, and finally for getting this I can add 4 and subtract 6. So in this manner we can get the sum of this window, and we can get the minimum sum. So I'll show you a demo of how that works using the same example, like how this can be implemented using an algorithm. So let's see how that algorithm works, the one that I just showed you. So here we have the same array that we have seen previously, and the window size is 4. So the first step was to find the sum of the window, which is 23 in this case. Now the next step is to slide the window. So to do that, we take 2 pointers, one left and one right, and so this is what we do. So to slide the window, we subtract the value that is given by the index on the left, and we add the value on the right. So by doing that process, we slide the window. So we'll see how that works. So right now this window sum is 23 and the minimum sum is also 23. Now when we slide the window, this is what happens. So we subtract the first value that was on the left, which was 10, and we add the value that was on the right, so that is 1. And now the window sum becomes 14 and the minimum sum also becomes 14. Earlier the minimum sum was 23, and since 14 is less than 23, we have the minimum sum as 14. Now let's keep doing this. So right now the window sum is 12, and so the minimum sum is also updated as 12. And now the window sum is 10 and the minimum sum is also 10. And once the right reaches the maximum size of the array, we stop our iteration. So this is how the sliding window technique can be used for finding the minimum sum subarray of a given size. And to find out our required answer in this case, so we got the minimum sum as 10 and total sum of the array is 31. So the required maximum number of candies that we can get is 31 minus 10, that is 21, which is the by taking the first 3 candies. So by using this algorithm, we are iterating over the array exactly once, and so the time complexity of this solution is of the order of n, where n is the number of elements of the array. So let me quickly code the solution in C++. So here I've just taken the input as per the input format. Now our task is to find the minimum sum subarray of size n minus k, and for that, as we have seen, we'll be using the sliding window technique. So I'm going to use a variable called window size, which will be equal to n minus k, and the sum of the window is initially 0. Now the first step was to find the sum of the window, that was the initial sum. So I'm going to use a loop for that. And so this loop basically finds the sum of the first window. The next step is to slide the window. So before that, we need some variables. We need the minimum sum, so which is initially equal to the window sum, and we also need the total sum of the array, because we have to subtract the minimum sum from the total sum to get our final answer. So I'm initializing these two variables, and then to slide the window, as we saw, we have two variables: left, which is initialized to 0, and the value of right, which is initialized to the right boundary of the window, which in this case is w. So right is w, and while right is less than the number of elements in the array, total sum plus equal to candies of right. So this is to find the total sum, and to find the sum of the window, what we did was we subtracted the value on the left, so window sum minus equal to candies of left, and we added the value on the right. So these two statements would basically slide the window, and then at each step, since we need the minimum sum, I'm going to be taking the minimum. So minimum sum is equal to minimum of the minimum sum comma the current sum of the window, which is window sum. And finally, once this also we increment both left and right so that the loop continues and the window slides, and finally we just have to print total sum minus minimum sum, and this would be our answer. So let's compile this. Okay, so the sample test cases have been passed, and we can submit this. And yeah, it got accepted, so all the test cases are passed. So just recapping the solution, first step is to find the sum of the current window, which we have done here, and then as seen before, we are sliding the window. So we take two pointers left and right and increment them in the loop. We subtract the value on the left and add the value pointed by the right pointer, and that would give us the, and at each step we take the minimum so that we get the minimum window sum, and our final answer would be the total sum minus the minimum sum. So I hope this solution was clear. Thanks for watching.